The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Abacus Decimal Subtraction, General Guidelines. Decimal subtraction is similar to the decimal addition, except in the case of few procedures, and let us discuss these before taking up exercises. Like the procedure followed in decimal addition, both the numbers involved in the subtraction problem should also be converted into whole numbers. In decimal addition, we mentioned that the addition processes may be taken up separately for the whole numbers and the decimal parts, and the difference added at the end. There is a slight difference in the abacus subtraction. Let us take the example 56.79 minus 42.56, and in this case undertaking two separate subtractions is possible, which is simple and straightforward too. Among the whole number parts and the decimal parts, we have to particularly look at the decimal parts of the numbers. Here, the first number is 0.79 and the second number is 0.56. The highest digit of the second number of the decimal part is lower than the first number, and therefore we can treat this as a separate subtraction, as the values do not run into the whole number section. 0.79 minus 0.56 is 0.23, which is again a decimal and not running into the whole number section. Or in the subtraction process, we are not involving the whole number. When we subtract the second whole number from the first, we get 56 minus 42, that is 14. Therefore, by combining the whole number and the decimal portion, we get the result as 14.23. Unlike the decimal addition, to get the final value, there is no further addition involved in the abacus subtraction. However, the problem becomes a little complicated when the highest digit of the first number of the decimal part is lower than the highest digit of the second number of the decimal part. For example, in the problem 42.18 minus 26.75, the whole numbers can be subtracted separately. However, for subtracting 0.75 from 0.18, we have to borrow a whole number from 42, which may slightly be a cumbersome process when we do the subtraction separately. In such cases, it is ideal to treat the numbers as 4,218 and 2,675 and adopt the normal subtraction procedure, and finally leave two dots in between whole number and the decimal part. If the preference of the child is to have all the numbers in the abacus itself in the subtraction process, and in the case of decimal portions involving more than 3 digits, we have to make slight adjustments in the decimal portions to convert them into 3 digits. In the addition process, we add some numbers to get the decimal parts into multiples of 10 and 100 in order to convert the same into 3 or 2 digits. And therefore, these added values used for the conversion are subtracted from the obtained values in subtraction in order to get the final number. On the contrary, in the case of subtraction, we may have to add the number used for conversion into the final result on some occasions and subtract the number from the final result on some other occasions. We shall deal with these differences separately through exercises at a later stage. Considering the pros and cons, it is ideal to convert the decimal numbers into whole numbers when the decimal part is less than 3 and simply adapt the general procedures of subtraction, and let us demonstrate these with some examples.